which means that you can't go walking in front of it, okay? And we're not going to call each other by their last names either, because this is open to anybody in the world who has a link to our live stream. So for privacy's sake, we got to be careful about that kind of stuff. Code names, yeah. Who knows? Maybe somebody's on there that we know too. It's a possibility. Or they'll be looking at it when it gets saved. Remember, you go to Google Classroom, and then within this document here that you open up at the very top, that's where you have your link. So if we clicked on that, this would open up the computer to me doing this, and then every time I said something, there'd be a 5-second delay. Every time I said something, there'd be a 5-second delay, and they just go around and around. Pretty hilarious when it happens. Any of those that stumped you, that you want to ask about? Any at all? How far did you get, Jackson? Which number?
20.
So you're almost done.
Yeah.
Which is the last one. Okay. I gave you number 8, right?
Well, 1 through.
Oh, this board doesn't work this way. What did you say?
No, we did not get number 8.
Really?
No, you chose all.
What's this down here? Oh, this must be the next day's lesson, huh? Is that today? No, that's advanced algebra. What am I looking at? Sorry. Okay. So I chose odd, huh? But I did choose 7?
Yes.
Okay. So just humor me, if you will. For number 7 in lesson 1-1. This is 2 times the quantity, 4x, subtract 5, plus 2. And we're supposed to evaluate this on x is 5 and x is -1. Like this. So, let's do -1. Is your hand up or are you just stretching?
I'm just stretching.
Okay, let's go. All right, so if I take 2 times 4, or times -1 minus 5, what's the first thing you're going to do with this one? In parentheses. So what's 4 times -1? Minus 5 is? -9. Multiplied by 2 is? -18 plus 2 is? -16. Or something like that. Okay. Was 20 the last one? Oh, 25 through 29. Okay, there, yeah, that's, okay, now I see my numbers. Got them straight. How about 19? AB times A over B times C over D. They say that this is the rule, AC over BD. But then you're supposed to use the fractions -2/11 and -3/5. So if you have -2/11 and -3/5, then you have -2 times -3 over 11 times 5, like this, yes? So if you're going to multiply that out, what would you get for an answer? What would you get? 6 over 55. Can we simplify that? No, we leave it as it is. Okay. So you had no questions about any of them. Did you check your answers for the odds periodically? You know, if you're really certain of your work, you're fine. Don't worry about it. But if you are not just dead certain, just check the odds in the back. Mark it. I don't have those little tabs, but I ordered some. Hopefully they'll be here soon. And I can give you tabs for marking different places in the book if you'd like those. But as soon as they come in, I'll let you know and everything. Okay, so let's jump ahead and take a look at describing patterns. And the idea with this next lesson here is that whenever we describe things that are happening, let me see what I want. I think it's going to be here. Whenever we describe things that are happening mathematically, we're supposed to look for patterns. And then what algebra is taking patterns that we observe and writing some kind of an equation for it. I mean, that's really what algebra is. It's really what math does. And the patterns are usually found in nature, or they're found in natural settings. So we don't make them up, and we don't just create things that we want to kind of come up with a non-scientific statement about. So nature could be looking at the price of things. Nature could be measurements that are taken. Nature is just the natural world, what's going on around us. So algebra tries to take what we see and write generalizations, and that's where the idea of variables come into play. So there's a couple of terms that we are using with this lesson. And I'll kind of try to deal with those first. And most of this is review. It's just going to look a little bit different, but the concepts, the ideas are things that we spent a lot of time on over the last 2 years. So 1-2 describing patterns. So a pattern is when we see some of the same things happening over and over again. An instance would be one example within a pattern. So if we had a pattern, let's see if I could do something here, like 2 times 7 plus 8 is equal to, let's just leave it like that. Let's just say, let's use this expression, 2 times 7 plus 8. And let's continue with this. Now we could say 2 times 4 plus 8, and 2 times 10 plus 8. So this is a pattern, because there are some things that are replicating themselves over and over. And if we are going to write a generalization of that pattern, we want to look for what's repeating itself and what changes. So as we look vertically, what's the first thing that you see in each of these? See a 2. Is it always a 2? Yeah. So we write that down. So this is the generalization. Then what do we see? Yeah, the operation multiplication times. So you write it down. Then what do we see?
The middle numbers.
Yeah, these are all different, aren't they? So if they're always different, that means they can vary. So that becomes a variable. X, everyone always chooses X. And then we see the addition is the same and the 8 is the same. So here's a generalization for that pattern. So all of this together is a pattern. This is a generalization. And then if we got in here like this, we took this one example in the pattern, that's an instance. So that takes care of kind of the beginning of this. And it goes further, because you're going to have to look at patterns like this. And you're going to have to come up with a generalization. In this case, that generalization is an expression. But it could be an equation. It could be what we later are going to call a function. But whatever we come up with for this generalization, it comes from that pattern and how the pattern establishes this generalization. That's a lot of extra words. Okay, a couple other things. Term. Term is given as one of our vocabulary words. And then factor is also used. So a term is a value such as, you could say an example would be the number 8. That could be a term. You could have x, that's an algebraic term, because it's a variable. You could have 3 times x, that's another term. And the reason that this is one term and not 2 terms is because it's paired together with multiplication or division. If I had like a over 3, that's a single term. But now if I went and I said, we have c plus 17, this is 2 terms because they're separated by addition. So if we separate things by addition or subtraction, they become individual terms. So in this example that we used here, there's actually 2 terms. There's the 2 times the 14, and then there's the 8. Or the 2x and the 8 when we look at the expression that we used here. And then a factor. What's a factor? Do you remember that one from last year or the year before? A factor is something that's used for multiplication. This is a coefficient, but it is one of the factors of 3 and x, because we can write 3x as 3 multiplied by x. So 3 is one factor and x is another factor. If you come up here, the 2 is a factor and the 7 is the factor, and together they make the product of 14. So factors are things that get multiplied. Those are the terms that are being multiplied together. So they give us, I think there's 2 different examples here. We want to take a look at these. Can you see this, or is it too small? What do you think? You can? If I make it a little bigger, is that okay with you? Okay, so you click on this and drag it out a little bit. Let's see how this goes. And I'm gonna put this on it, see how that looks. This smartboard has been difficult to write on though, so I don't know how it's going to do today. Let's see. So here's what they give us. They give us a situation, and then we're going to look for a pattern. It says at the start of the school year, the library has 3,600 individual magazines. Each month they get 22 new magazines. So the first thing we got to do is complete this table, and then we need to come up with a variable for the part of the pattern where the number keeps changing. And we need to write a generalization or an algebraic expression, in other words, for what's happening here. So at the beginning of the school year, there's 3,600 copies. And they write the pattern as 3,600 plus 22 times 0 because it's 0 months. So in this case here, we might write 3,600 plus 0. That's not real clear. Can you follow me? Or should I put it on the board? What do you think? I can't hear you.
I can follow.
Can you? Okay. All right. So then, if we go to 1 month, in order to calculate how many magazines there are, what would you do? 3,600 plus 22, is that what you say? Okay, so we'll say 3,600, that came out clear, plus 22. And if we write it as a pattern using the multiplication, 3,600 plus 22 times what? I've got to rely upon you 3. So this is 3,600 plus 22 times how many months? 1. So let's just keep going down through the pattern. Here there's 3,600 plus 22 plus 22 after 2 months. But we could rewrite that a little more neatly with 3,600 plus 22 multiplied by 2 months. Thank you. Oh, this is 3,622, isn't it? And then you go down to the 3rd month, and you just say, well, that's 3,600 plus 22 plus 22 plus 22. This is not such an important column. The pattern is more important. So we're going to say that that's going to be times 3 months, and then we're going to have 66 magazines. So when we look at this, let me go over to the board. But if you look at that pattern that gets established, if you're going to write a generalization, sort of with the same idea what we did earlier, we look down, that does not change. There's always addition, there's always 22. What are we going to do with 1, 2, and 3? How do we rewrite that? Use a variable. So what's the appropriate variable if we're talking about months? Yeah, choose M. We'll get away from using X for everything. So this is an algebraic expression because of the variable. These first ones that we did here, the first 3 were numerical expressions because they're just numbers. These are numerical. This is algebraic. So that's one thing you need to be able to do in your homework, is come up with an expression. You don't need an equal sign, just an expression for a pattern. And then there's the second example. So it's a family of 5, I think, or something like that. And this family of 5 is doing some vacation-y kind of things. And what we're supposed to do is we're supposed to take a look at the costs and try to establish the pattern and write it algebraically. So with this one here, we've got 2 adults, we've got 3 kids. These are the prices of different things: ferry boat, movie, water park. These are the prices for children, those are the prices for adults. And the way they walk us through this, and you guys are all going to be at different stages of this. You know, first of all, you might need to be able to do this to write your expression. Some of you might just be able to read and look at it and process it all in your head. I'm fine with whatever way you want to get it done. But definitely know what it means for something to be an instance. Know what it is if you have to write out a whole pattern. And know what it is when you have to write an algebraic expression. So this is one instance right here where they take 2 adults times 15 bucks plus 3 kids times 8. And that's how you get the family's cost for just doing the movie. How would you write the ferry boat as a family cost? Okay, 2 times 22 plus 3 times 10. And then how do you write the water park? Two times 10.
Plus 3 times 4 plus 50.
So in each of these, what changes? What's different in the first compared to the second compared to the third?
The adult child person.
Yeah. It's this right here. That's what they charge. So these become the numbers which are going to be variables. And they give us a key here, and they say, well, let A be the adult ticket price. So these are all going to be A. When they say C, these are going to be the child prices. So we just go through this pattern and we look at it. And we see that it's always 2 because that's the count of adults. So it's 2 multiplied by the adult ticket cost plus 3 multiplied by the child's ticket cost. So there's your generalization. There's your algebraic expression. 2 variables because 2 different prices, one for an adult, one for a kid. So have we seen stuff like this before? Yeah. So these first 2 chapters of the book are basically review and get used to a little bit of how they write things and how they present them. some of the ideas might be a little more complicated than what you've seen in the past. They might use numbers that are a little more involved, but it's the same basic concept. So, commutative property of addition and the commutative property of multiplication. Do take time to write these down. I'm not going to generally have you recite them, but what I might do is make sure that you can use them. You've been using these, you've been seeing these for a long, long time. Recognizing them can be important. So, this works for all real numbers, both of these. So for all two lines, capital R, all real numbers, A and B, we would say A times B is equal to B times A. And same thing holds true for addition. For all reals. A plus B is equal to B plus A. That's it.